In the intermediate first year, we have 14 units. In that 14 units, we are going to discuss about the mechanics. In that mechanics, we have consist of 2 units. In the 2 units, the first one is a motion in a straight line. What is meant by the mechanics? Whenever the motion of an object or motion of a body, we will discuss about the motion of a body, that is in the mechanics. In that mechanics, some of the branches is there. Those are, first one is kinematics. Kinematics means it's the study of a branch of a mechanics as well as physics, and the study deals with the motion of an object without a reference of the cause, without reference of the cause of motion. Means we don't discuss about the cause, why that body is in motion. Only we will discuss about that when the body is in motion, then what are the parameters are involved during the motion. So in that case, in kinematics, it's a study of the branch of mechanics. Study deals with the motion of an object without a reference of cause of motion. Without cause of motion, we don't discuss about the cause. In that case, here that is a kinematics. The next one is a kinetics or a dynamics. In that kinetics or dynamics, we will discuss about the motion of an object, and as well as a cause of the motion also. We discuss both of them. Means the motion of an object, what are the parameters involving during the motion, and why the body is in motion, what are the factors involved for the motion. So that type of topics we will discuss in the kinetics, or this is referred as also dynamics also. Dynamics also means whenever the body is in motion, why that body is in motion, we will discuss about the cause of the motion also. That is about kinetics. The next one is statics. Statics means, here the statics means we will discuss about the motion of an object whenever the sum of the set of the forces is acting, the body will be in equilibrium position. If the body is in equilibrium, then when the set of forces are acting on the body, then the body is in equilibrium. That study deals with this, the study will do in the statics. That means the study deals with the motion of an object of an object in equilibrium when the set of forces acts on a body. Set of forces act on a body. That is a statics. The next one is a hydrodynamics. Hydrodynamics means it deals with the liquids. Whenever the liquids is in motion, then mostly liquids, the motion of a fluids, when the fluids are flowing, then we will discuss about that hydrodynamics in that case. The next one is hydrostatics. When the fluids are in equilibrium condition, mostly liquids, we will discuss about it. In that case, the study is called as a hydrostatics. When the liquids are flowing in equilibrium condition, then that will be the hydrostatics. The last and final one is aerodynamics. Aerodynamics means the study of an object, motion of an object in a gas media. When the object is traveling in a air or in some of the gas, then we will discuss about that whenever the object is in motion in air media. About this, these are the basic, these are the branches of mechanics, and in that case, in the kinematics we are going to discuss about the 2 topics is there. The 2 topics are we have in the first year intermediate education, that is motion in a straight line, and another one is motion in a plane. In the motion in a plane. So here we are going to study about first motion in a straight line. Motion in a straight line. In motion in a straight line, which is having the weightage of 4 marks, in intermediate first year public examination. So what are we going to study in the motion in a straight line means when the body is in motion. First of all, what is motion and what is rest? Means if a body is changes its position with respect to its surroundings is called motion. If does not change its position with respect to its surroundings is called as at rest. Means rest means if the body is changes its position, if the position of a body does not change with respect to its surroundings is called rest. If the body position changes with respect to its surroundings is called as a motion. That means if the body does not change its position with respect to its surroundings, is called a rest. If the body changes, its position changes with respect to its surroundings is called a motion. Here that rest and motion are both will be relative. Here is that in one situation body can be rest, and in another situation that same body will be in motion. Like that, for example, when we are traveling in a bus or when we are traveling in a train, in some other bike, we are at rest with respect to our co-passenger, and we are in motion. We will be in motion who are standing on the platform, or we are standing in the outside the vehicle, whatever we are traveling outside the vehicle. According to that person, we are in motion. That is the one situation. And according to us, if we compare with the co-passenger, we are at rest. That means the same person in two situations, there is a rest and there is a motion. Means in that case, we can say there is no absolute rest and there is no absolute motion. Once again, rest means if the position of a body does not change with respect to its surroundings is called a rest. If the position of a body with respect to its surroundings, if the body changes, means if the position of a body changes with respect to its surroundings is called a motion. So that we can say rest and motion are both relative, because of during in one situation if a body is at rest, that same body will be in another situation can be in a motion also, like that. Because of whenever we are traveling in a bus, we are at rest with respect to our co-passenger, and at the same time we are in motion with respect to the other one who stands outside the bus or on the ground or on the platform. So that case there is no absolute rest and there is no absolute motion. Here is the definitions. You can read, you can write also, you can note. So if the position of a body does not change with respect to its surroundings, it is said to be at a rest. If does not change, and motion means if the position of a body changes with respect to surroundings, it is said to be in a motion. The both are relative. It means a body in one situation can be at rest, but in another situation the same body can be in a motion. Like that, for example, already just we said, we discussed now, when a person is in a moving bus, is at rest with respect to his co-passenger, and the same person in motion with respect to observer standing outside the bus or on the ground. That means we can say that so there is no absolute rest and no absolute motion. Now we are going to discuss about the types of motion. The motion are how many types? So types of motion of a body. In the types of motion of a body, we are going to discuss about that. First one is a rectilinear motion. Rectilinear, or also we can say that, or a translatory motion. Translatory motion. Rectilinear motion or a translatory motion. So what is rectilinear motion and what is translatory motion? Means translatory motion. So first of all, rectilinear motion means when a body or point mass of a body, when heavy object a body or a point mass of a body moving along a straight line, when a point mass body or when a object is moving along a straight line is called as a rectilinear motion. When a body or a point mass body also, we can say that point mass body, in a body and a point mass body is moving along a straight line, along a straight line, means if the body is moving along a straight line, then that is said that it's a rectilinear motion. And when the rectilinear motion can be called as a translatory motion, means here the rectilinear motion can be called as translatory motion when it's constant particles also moving along the same direction, same parallel lines according to the straight line, as well as like a straight line. Means whenever consists that is translatory, the point mass body cannot be taken in the translatory motion only when the heavy bodies are, means some of the, whenever the body is containing that some of the particles or some of the molecules contain, then only it called as a translatory motion, because of that molecules has to translate from the one place to the another place along a straight line with the parallel lines, parallel in a given time, in a uniform time. So that's why if in case of the particles which is having this, they have to move along a straight line. According to this, whenever it is rotating, then they will completely move along a straight line. Wherever this is called as translatory. Translatory, its constant particles also moving along parallel to each other along a straight line. If the body is also moving along a straight line, then only this will be the rectilinear. All bodies can be rectilinear and translatory motion. All bodies can be moving along a straight line. Whenever the body is moving along a straight line, that can be say as a rectilinear motion. Translatory motion also whenever its constant particles also moving along a straight line. When they are fixed at the sum of the equal distances, when the moving along a straight line without colliding each other, wherever the particles are moving along a straight line, then it is parallelly, then it is also called as a translatory motion. Means here the one these are rectilinear and translatory motion can be uniform and non-uniform. These motion can be uniform and non-uniform. What is meant by the uniform and non-uniform? In later we will discuss about it. What is meant by the uniform, non-uniform? Means here uniform means when the particles are traveling in equal distances in equal intervals of time. Means whenever the particle traveled first meter in 1 second, that has to move in the second meter also in 1 second only. In the third second also it has to move in 1 second only. Means equal distance traveled by a particle in equal times of interval is called as a uniform. Or in this case of non-uniform, non-uniform means if the in equal distances in unequal intervals of time, or unequal distances in equal intervals of time. Means in the first second if the body moved into the 10 meters, in the second 5 meters, then that will be the non-uniform. In uniform means in each and every second that body has to move in equal distances. In non-uniform means that will not be equal. If the time is same, the distance are not equal. If the distance is same, the time will be not equal. So that is called as a non-uniform. Simply we can say that. Briefly we will discuss later in the concepts. So the motion can be uniform or non-uniform. Means a rectilinear and translatory motion. The next one is circular or rotatory motion. Circular or rotatory motion. Circular or rotatory motion. This is the first one and this is the second one. Circular or rotatory. Here circular or rotatory motion means if irrespective of path, if a particle moves around a fixed point, permanently, that path is called as a rotatory motion. That path is called as permanently, that motion is called a rotatory motion. rotatory motion. And also we can say that rotatory motion will be circular when the path is a circle. If the path is circle, if the path is a circle, then the motion is called a circular motion. Circular motion means if in case of the body is moving around a fixed point like this, irrespective of path, moving around a fixed point, permanently the body is moving around a fixed point irrespective of path. That path can be said as a rotational. If this path is a circular, then that is called as a circular. Here we can say that every circular motion is a rotatory motion, but it need not to be that every rotational motion be circular. Means every circular motion is a rotational motion, but it need not to be that every rotational motion to be circular. Don't be confused. Here every circular motion is a rotational. Every circular motion is a rotational, but every rotational need not to be circular. Here is that every circular motion is a rotational motion, but every rotational motion need not to be circular. Here we can see that this motion is a circular as well as this can be said as a rotational also. But irrespective of both, this is not a circle, but it's a rotational. But it's a circle, but it will be the rotational, and means whenever the motion of a body around a fixed point, it traveling around a fixed point irrespective of path, either it is moving or circular or it is not moving or circular. If the body is moving around permanently around a fixed point, then that will be the rotational motion. If the path is a circular, then only we can say that that's a circular motion. Once again, when a fixed point a body is rotating, this fixed point is called axis of rotation. When a body is moving, the point where the body is moving around around an axis is called as a rotation, axis of rotation. This is about a circular or a rotational motion. And another one is once again, circular or rotational motion means irrespective of path, if an object, particle moves around a fixed point permanently, that motion is called as rotatory motion. If the path is a circle, then that motion will be the circular motion. And every circular motion is a rotational motion, but every rotational motion need not to be the circular motion. And where the point where the object is moving around the fixed point, that point is called as point of rotation. And a perpendicular line passing through the point of rotation means this point, when the perpendicular line passing through this will be the axis of rotation. From this point, the perpendicular line passing perpendicular to the plane where the body is there, then that axis is called as axis of rotation. And at the point where a fixed point where the body is moving around the point is called as a point of rotation. This is about a circular or a rotational motion, rotatory motion. Next we are going to know this oscillatory motion. In this oscillatory motion, if a particle moves to and fro, motion of a particle means when a particle is moving to and fro, back and forth from its mean position or its definite position is called as a fixed point, is called as a oscillatory motion. If a body moves to and fro or back and forth from its fixed point, that fixed point is called as its mean position in definite time of interval, indefinite time means here definite time of interval means when a body is moving, if you consider it's a body which is a suspended version, then whenever it is moving to and fro from its fixed position, means it is moving in this direction and in this direction. Now for example, swing, while we are singing, then the motion to and fro motion is called as oscillatory motion. When the body is about a fixed point, we are moving from the fixed point. If we go from fro and back, then we are coming from the same point and moving from the same point. We are reaching that same point, means whenever the body is staying at rest without any movement, if the body is staying at rest, that position is called its fixed point or its mean position. It's a mean position. It is nothing but where the body is at rest, means that is not the, whenever the position, when there is no any force is acting on that body, if the body is at rest, that will be its mean position. Whenever it is suspended, then it will stay at rest. That position is called as a mean position, that is equilibrium position, that is fixed point. So if the body is moving to and fro from that fixed point in definite interval of time, means it's a uniform motion. It's a uniform motion, means when the body taken to the time to complete oscillation is equal whenever this. So that's why here the body moves to and fro or back and forth from its fixed point, means its mean position, from its mean position. This will be its mean position. This position is called as a mean position. So here it is that the definite interval of time is called as a oscillatory motion. This is about the types of motion. Once again, rectilinear or translatory motion means when the body is moving along a straight line is called as rectilinear motion. If its constant particles also moving along a straight line parallel to each other is called translatory motion. Means if your body moving a straight line, it means rectilinear. Its constant particles also moving along a straight line parallel to one another is called translatory motion. And the second one is rotatory or circular motion, means irrespective of path, if a body is moves around permanently about a fixed point, that motion is called rotatory motion. If that path is a circular, then that motion is called a circular path. And a point which is fixed around the body is moving, that point, that is called as a point of rotation. And the perpendicular line passing through the point of rotation from the center of this perpendicular to the plane, moving from the point of rotation perpendicular to the plane is called as axis of rotation. And in that rotational or circular motion, every rotational motion need not to be circular, but every circular motion must be rotational. Every circular will be rotational motion, but every circular motion, every rotational motion need not to be circular motion, because of orbital, means earth moving around the sun in elliptical path, not circular. That is also rotational motion, like that. So here is another one is oscillatory motion. If the body moves to and fro or back and forth, means like a swing. When the motion of a particle moving to and fro from its fixed point or its mean position in definite time of interval is called oscillatory motion. These are the three types of motions.
Earlier class we discussed about what is rest and motion and types of motion, means rectilinear or translatory motion and rotatory or circular motion and as well as oscillatory And also about that motion means if the body is moving along a straight line, then what is the motion? The way of motion means when your body is moving along a straight line in any coordinate axis, maybe any coordinate axis, then if the body is moving along x axis or along y axis or along z axis, is considered as a one-dimensional motion, that is also called as a rectilinear motion, and means like a car, whenever the car is moving on the road, it is a rectilinear motion because of it is moving along a straight line, and as well as a train also moving along a straight line like that. When your body is moving along a straight line in any one coordinate axis, if the body is freely falling from certain height, from that is also moving along a straight line. Like that, if any body is moving along a straight line is called as a rectilinear, and at the same time it's any coordinate, maybe x axis or along the y axis or along a z axis, any one axis, then that is called as a one-dimensional motion. If the body is moving in a curved path, means specifying comparing means whenever the position can be say between the according to the two coordinate axis, that position can be examined by with the two coordinates, specified by the two coordinates, then if the body is said as that is moving in a plane, means all curved paths which are moving, then that is called as a two-dimensional motion. If any object moves in such a way that it covers two directions simultaneously, its motion is known as a two-dimensional motion. Like all the motions which are having the curved paths means if in case of general example for that, if in case of a wall clock is beaten on the wall, if you want to say the position of the wall clock, then we can consider that from that the vertical corner and the horizontal corner which is having in the room, means if this is considered as a room, then if we put the wall clock in this place, then if you want to say the position of the clock, then you can say from this also and from this also, and this corner and this corner. This is considered as y axis and this is considered as x axis. So that's why according to the x and y axis we can say the position of that wall clock. Like that, if in case of the lizard on the wall, then if we want to say that whenever that is on the means here the position which can be specified by using the two coordinate axis is called as a two-dimensional motion. If the path is in motion, means if the body is in motion, here is also if the body is in motion, if any body is in motion between the two axes, means that position can be specified by the two coordinate axis is called as a two-dimensional motion. All curved paths which is moving in the plane can be considered as a two-dimensional motion. If the third one is a three-dimensional motion, if the flying kite, if the position of an object which is moving, it can be specified by the three coordinate axis, which can be specified by three coordinate axis can be specified there, then it is said to be that is means flying kite in the air, and as well as when the fly is in the room. If we was stand in the room, this is the piece of chalk. To specify the position of the chalk, we should consider the three coordinates. Means here is the x-axis, y-axis, z-axis. According to the y-axis, z-axis, x-axis, so we can specify this position of the object. Means this is in the three-dimensional, which can be specified by according to the x-axis, according to y-axis, and according to z-axis also. So that's why we can say that if the fly is on the room, then if you want to specify the position of or movement of that fly, then we can see according to the x-axis, we can say according to the y-axis, according to the z-axis. These are the three types of dimensional motions, that is 1D, 2D and 3-dimensional motions. According to the if the specify the position, if the body is moving along a straight line, to specify the position of any one coordinate axis, we can specify the position of an object whenever it is in motion. If we specify by using the one-to-one coordinate axis, then that will be the one-dimensional motion. If in case of the position of an object can be specified by the two coordinate axis when it is in the plane, then that will be the two-dimensional motion. If we can specify the position of an object by using three coordinates, then three coordinate axis, then that will be the body will be in a three-dimensional motion. These are the three types of according to the way of the body, motion of the body, then we can say that either one dimensional, two dimensional, and three dimensional. Now in this motion in a straight line, we are going to discuss only about that motion in one dimensional motion. That is, in case of a body is moving vertically or horizontally. When the body is in motion, then what are the parameters are involved in the during its motion? Means according to that, if the body is traveled from one place to the other place, it can say that it moves some distance and it displaces from this place to the other place. And also while this body is moving, and it consists of some of the speed, means the velocity. And whenever with the increasing speed, it is called as acceleration. If in case of by the decreasing velocity, it is called a retardation or a deceleration. These type of parameters are involved when the body is in motion. Let us see what are the parameters are involved during the motion of an object along a straight line. In the parameters, motion of parameters, now we are going to discuss about distance and displacement. When the body moves, travels from one point to the other point, it is said to be that the body is traveled some distance. Means here, what is meant by the first of all, what is distance? We are going to see first of all distance and displacement in the parameters of motion. Distance, displacement. So, in the distance and displacement, what is the distance means? When the body is traveled from one point to the other point, means when the body is traveled from one point to the other point along a straight line, either along a straight line or maybe the different path, maybe different path from A to B. Body traveled from a different path. Then the actual length of the path, the total path, means the actual length of the path traveled by or traversed by a particle, moving particle, is called a distance. For example, from body A to B traveled 25 kilometers of distance. That will be the distance of the particle. Means the total length of the path traveled by a particle is called the actual length of the path. The total actual length of the path traveled by a particle is called distance. It's called a distance. It is having only magnitude but no direction, because of it is having the different directions in the respect of path. The total length, the actual length of the path we have direction. So that's why it is having only magnitude but no direction. So that's why it's a scalar quantity. Scalar quantity means the body is a physical quantity which is having only magnitude but no direction is called a scalar quantity. In that case, here the distance is having only magnitude but no direction. So that's why distance can be called as considered as it's a scalar quantity. It's a units. It is measured in meters, centimeters. The SI unit of the distance will be the meter, and CGS unit of the distance will be centimeter. Once again, the actual path of the actual length of the path, the actual length of the path traveled by a moving particle is called distance. It is having only magnitude, no direction. So that's why it's considered as a scalar quantity. Its units are centimeter, meter, kilometer, and in that case SI unit is the meter. And if the distance cannot be negative, if the particle is moving from one in this place to the 2 meters, that cannot be minus, because it is considered as only plus. The distance always considered as a positive only, it cannot be zero also. Whenever the body is traveled from some of the place, then it cannot be zero, and as well as it cannot be negative. If the body particle is at rest, then only we can say that the distance is zero, because of that body is not in motion. If the body is in motion, then distance cannot be zero, and that is do not decreases with that time. When the body is in motion, distance never be negative, and it is decreased, do not decrease with the time. Means when the time is going on, when the body is in motion, then always the distance is increasing positive. It cannot be negative, and also do not decrease with the time. That is about the distance. If we come for the displacement means when a body is traveling from one point to the other point by moving in some of the directions, different directions, and from the whatever the length is there, then the along a shortest path, means from the initial point to the final point, we can draw the along the straight line in a specified direction. If we draw a line from the initial point to the final point, then that will be the displacement. Means the shortest path, the length of the shortest path, the shortest distance between the initial and the final point of the particle in a specified direction is called a displacement. And then if we traveled from one place to the, we are going to the college from our home. So whenever we are coming from our home, we will wander in some of the roads. We will there is a turn is there. That is the total length of the path can be considered as a distance. But when we draw a straight line from your home to the college, then that will be the displacement. Means the shortest distance between the initial point and the final point. Initial point to the final point is called a displacement in a specified direction. That is examples we will see. It is considered is a vector quantity because of displacement is having magnitude, and also we said that in a specified direction means the initial point to the final point. There is some of the direction is there from initial point to the final point, or final point to the initial point. There is some of the direction is there. So here you can say that the displacement can be 0, negative, and also positive also. Here we are going to see how it is possible. The vector quantity is a vector quantity because of it is having direction and magnitude, so that's why it's a vector quantity. And SI unit of the displacement is also considered as meter. It is also measured in meters, kilometers, centimeters. The CGS unit for the displacement is a centimeter, and SI unit for the SI unit is meter. And here some of the examples we are going to see how to clarify about what is the difference between the distance and the displacement. And then if the body is moving along a straight line without changing its direction, then it will be distance and displacement will be same. In case of body is moving along a straight line, means body started from A and it traveled towards the some of the direction point to the B, traveled for 3 kilometers. The shortest body is moving along a straight line without changing its direction, then we can say that here is the 3 kilometers is the distance, and displacement is also we can draw with the straight line in a specific direction from initial point to the final point is this only. So that's why we can say that this is the displacement and this is the distance. So here when the body is moving along a straight line, the displacement and distance be equal. And the displacement will be 0. Some of the times displacement will be 0 because of, here see that some of the examples. Here when the particle is traveling from A to B in a curved path, that is AB, and that is called as the total length of the curve can be considered, AB curve can be considered, that will be the distance. The straight line from A to B, from initial point to the final point, we draw the specific direction, that will be A to B. This will be the displacement. Always displacement will be less than the distance. Do not exceed displacement. Do not exceed the distance. Always it is less than or equal to the distance only. Next, here the A will be the curved path, total length of the curved path A will be the distance, and the shortest distance from the initial point to the final point will be the displacement. Here the other one is a particle started from A and traveled towards the B for 3 meters, and from the B to C for 4 meters. Then here the distance will be, the traveled distance is AB plus BC be the distance, so that's why 3 meters and 4 meters, totally 7 meters will be the distance. And the shortest distance which can be drawn from the initial point to the final point, this will be the displacement. Means the shortest path drawn from the initial point to the final point will be the shortest path. So that's why it is called as a specified direction. Okay, specified direction we draw the line. So that is called a displacement, that is AC. AC be the displacement, that is 5 meters. By doing the Pythagoras method, then we can get that line 5 meters. And the third, the displacement never exceeds distance. Already we said that when the particle is moving from the arc of a circle. This is the arc. When it is traveled in arc that is P to Q, which is of circle of radius r. Then its distance will be thus. It is making subtended angle theta from the initial point to the final point into the center. Is the theta be the angle which is subtended angle. Then whenever it is traveled, the total distance will be r into theta. Distance will be r into theta. So here it is r into theta. The next, when the displacement which is taken, the shortest path drawn from the point, the initial point to the final point in a specified direction, then it is said that the displacement will be 2r sine theta by 2. 2r sine theta by 2. We will get that from these points. We will get this by taking this triangle. We can get that sine theta. That is this angle. We can get that 2r sine theta by 2. Here is that we are going to see some of the important points about the distance and the displacements. Displacement can be 0 when the particle has started from initial point and traveled over some of the distance and came to the same point and returned to the same point. Then displacement will be 0. Like if the point started from A, the particle started from A and traveled like this in all the distances and came to same position, then the total path, the path can be considered as distance, and displacement will be 0. Distance will be something, some of the part which in case of travel distance is considered as 10 meters, then distance will be 10 meters, then displacement will be 0. Whenever the body or particle travels, started from the initial point and returned to the initial point after traveling some of the distance, then displacement will be 0 and distance will be some of the total length of the path which has traveled. That is generally we can say that a particle can travel some distance without displacement. This is displacement and this will be the sum of the distance. So that the displacement can be less than the distance and current comes for the curved motion. So the displacement can less than the distance because of whenever the body travels in certain distance, always displacement is less than the distance. Or when the body is moving along a straight line, then only displacement which is equal to distance for straight line motion, and displacement is less than for distance for a curved motion. Whenever it is moving a curve, this will be the distance, and this is the displacement which is less than the distance. Here is the. So we can say that again, the particle moves whenever the displacement never exceeds the distance. Displacement will never exceed the distance. Here is that. Whenever the displacement can be 0, can negative, and can be positive also. Displacement can be positive, negative, or 0 from here. Whenever the body is reached to the same, return to the same point, then will be 0. Whenever the body is traveled and returned from the same path, retraced from the same path, then we can say that whenever the direction of opposite, then this displacement can be negative. We will calculate the negative. Then positive means whenever the body is traveling along some of the straight line, we can say that displacement will be positive. This is about one of the parameters of motion, that is distance and displacement.
Another parameters of motion means in earlier video we discussed about the parameters of motion, that is distance and displacement. Distance and displacement. What is distance and what is displacement, and what are the positive and negative values of the distance whenever we take, how it will, the displacement can be 0, positive and negative, and distance can be positive always, can when with the time it does not decrease with the time. And now we are going to another parameters of motion which depends on the distance and displacement, that is the speed and velocity. Speed and velocity. Here we are going to know this, what is speed. What is speed? Speed means the distance travelled by an object in unit time. Means if the body travelled from one point to the another point in certain time limit, in unit time, it is given that 1 meter or 1 second. If the body travelled 1 meter in 1 second, then that is the speed, or that is the speed of that body of an object. Then if the distance travelled by a body in unit time is called as a speed. The distance travelled by a body in unit time is called as a speed. That is, speed is equal to distance travelled by time taken. Means we know the distance travelled taken as d and time, total time taken t. S is equal to d by t. We can say distance can be considered as a total distance travelled d, and t speed can be calculated as v with denoted with v also. Then it's a scalar quantity because of it does not give any idea about the direction of motion of a body. Speed does not give any idea about the direction of motion of a body because of in this speed, in this direction only the speed cannot give about the direction, does not depend on the direction. So that's why we can say that whenever we are moving, whenever we are riding the bike, we can see the meter, speedometer, then we are going on 50, 60, 70. In what direction we know? That doesn't know what is the direction. It does not give any idea. It gives only the how much the distance it is travelled in unit time. It gives only idea. We can see in the speedometer km by h means kmph means a kilometer per hour. That can be moved. If in case of we are going for 60, then if we are going on the 60, then we can go in 60 means 1 minute. 160 kilometers in 1 hour means 1 kilometer per 1 minute. Like that. Here is also we can say that speed does not give any idea about the direction of motion of your body. So that's why it doesn't have any direction, only it is having some of the magnitude only. So here it is that it's a scalar quantity. It is measured in meter by second, means distance is measured in meters, time is measured in seconds. So meter by second, that is meter per second. We can say it as a meter per second or meter second universe. Dimension formula, we can measure the dimension formula. Meter is a length. Dimension formula means if in case of the units can be derived in denoted in terms of fundamental units, that is mass, length, time. In case of mass, length, time, if we notify that, if we give the unit, there is a dimensional formula. M means length, meters, length is having the 1, so L power 1, and second means time power minus 1, it is time power minus 1. There is no any mass about in this unit, so that's why M power 0. We can say dimensional formula is M power 0, L power 1, T power minus 1. So this is the dimension formula of speed, and another thing is this does not give any idea about the direction, so that's why it's a scalar quantity. Scalar means here only the physical quantity having only magnitude but no direction is called as a scalar quantity. So SI unit is equal to meter per second, that is meter per second. Dimensional formula is M power 0, L power 1, T power minus 1. Then speed can be positive, but it cannot be and it cannot be negative. Speed can be positive or zero speed, but cannot be negative. Speed cannot be negative. If the body is not moving, then zero speed. That can be said that, and if his body moving, that's the positive value of the speed. But the speed cannot be negative. Cannot be negative. So here is that speed can be positive and zero but cannot be negative. As well as then what is the average speed? What is meant by the average speed? Means if your body, if we are traveling for 10 kilometers, if that body travel in the 10 kilometers, first distance, first 1 minute is traveled in 1 kilometer, and second minute traveled in 2 kilometers, and third kilometer traveled in 0.5 minutes. Means here the different distances traveled in different times, means different times. Then the average speed of the total journey, we can say that the ratio of total distance traveled by total time taken. Means if we want to go from the one place to the another place, means from A to B, from A to B, we want to go to A to B along a straight line. From A to B, here this is the first point, consider this is the second point, this is the third point, and this is the fourth point, which is the stages between the A and B. That A to 1, point 1 taken 1 minute time to travel, and 1 to 2 taken 2 minutes, and here that 5 minutes, here 3 minutes, here 4 minutes. The distance are different, maybe are equal, maybe either 2 kilometers, 1 kilometer, 3 kilometers, 4 kilometers, 5 kilometers, like that. The total average velocity during this total journey, average speed of the body during this, whenever it started from A and reached to the B, then the ratio of the total distance travelled by an object to the total time taken, means average speed is equal to the total delta S, means if in case of the object travelled total distance is delta S, change in distance by total time is change in delta T. So we can say that the average velocity, we can write that total time taken, total distance travelled by total time taken. If in case of, if an object is traveled a distance of delta S in time of delta T, then we can say that the average speed V average is equal to delta S by delta T, means total distance travelled by an object by total time taken to travel from A to B. Total time taken travelled A to B. This is about average speed, means the ratio of the total distance travelled by an object to the total time taken. Total time taken is called average speed, that is delta S by delta T. That means total distance travelled by total time taken. Next we are going to know this instantaneous speed. Instantaneous speed means, we know that what is instantaneous at a certain particular time of interval, at a particular time, at a certain particular time is called as instantaneous. Means if the body is in motion, means from body is moving from A to B, time totally taken, that is 30 minutes to travel from A to B. Then at a particular instant of time, at the time of 11 minutes, I am taking that at time of 11 minutes, what is the speed of a body? What is the speed of a body? That will be the instantaneous speed, means the speed of an object at a particular instant of time, during its total motion, at a particular instant of time is called instantaneous speed. Means body travelling from A to B, taken the total, if we consider it's a total time taken the 30 minutes, then we want to know what is the instantaneous speed of a particle, of an object at a particular instant of time at 11 minutes. At 11 minutes, what is the speed of the body? That time the speed which is contained by an object is a instantaneous speed of an object. That is a speed of an object at a particular instant of time is called instantaneous speed. That is instantaneous speed is equal to limit delta tends to 0, means there is no change in time, always because of it a particular short interval of time. So that's why there is no time difference. So limit delta tends to 0, that is delta S by delta T, means it is short interval of time, that is which meant by there is no change in time interval between 0. Means at a particular, if in case of we want to know that 11 minutes 10 seconds, then 11 minutes 10 seconds is the started time and 11 minutes 10 seconds with the ended time at a particular instant of time. So here there is no time change, so change in time will be tends to 0, that is delta S by delta T is equal to ds by dt. This will be the instantaneous speed, means the speed of an object at a particular instant of time is called instantaneous speed. Means when during the time at a particular time of interval, what is the speed of a time, that the speed is called instantaneous time. At a particular instant of time is called instantaneous speed, means at a particular instant of time. Then here we should know that what is uniform speed and non-uniform speed. Just listen carefully, because it's the important thing is uniform and non-uniform. What is uniform and what is non-uniform, we can get further also. So listen carefully. What is uniform speed? Uniform speed means all we know that whenever we are in school, all the students can wear the same dress, that is uniform. Uniform means same. Means if an object is moving same distances in same intervals of time, means equal distances in equal intervals of time. All are equal in our school, right? So school or college, whenever we are wearing the uniform, then all students will be equal, means equal time. So to show that here uniform means the body travels equal distances in equal intervals of time. Means if the body is traveling from this place to this place, consider it say 10 meters. 10 meters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 meters. So here is that it is moving from A, B, C, D, E, F, G, H, I, J, K is the points, the equal distances partitioned equally. So if the body is to travel from A to B has taken that it is a 10 meters distance, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 partitions are divided. The first from when the body is traveled to A to B taken 1 minute, then second body also has to second distance also take to 1 minute, third distance also 1 minute, fourth distance also 1 minute. Means in equal distances traveled by a body, equal distances traveled by a body or equal distances traveled by an object in equal intervals of time, means 1 minute, 1 minute, 1 minute is equal 1 meter, 1 meter, 1 meter, or 2 meters, 2 meters, whatever the distance is there, but it should be moved, that body has to move in equal distances in equal intervals of time is called uniform speed. The speed of a particle should be equal, the body should be traveled in equal distances in equal intervals of time is called as a uniform speed. Uniform speed means if the body, if we are traveling from one place to the another place which is having the 30 kilometers, the first 10 kilometers has completed in 1 hour, and second 30 kilometers, second 10 kilometers also has to take the 1 hour, and third 10 kilometers also 1 hour, means equal distance 10 kilometer, 10 kilometer, 10 kilometer, and equal time 1 hour, 1 hour, 1 hour. Means total time has taken to travel 30 kilometers is 3 hours. If we take, then the equal distances traveled by in equal intervals of time, that is the uniform speed. A body traveled equal distances in equal intervals of time is called uniform speed. And if in case of a non-uniform, which is opposite, means either the body is traveling unequal distances in equal intervals of time, means if just now we discussed about when the body is traveling 30 kilometers, when we are traveling 30 kilometers, first 10 kilometers we started at the time, we completed it in 10 minutes only. If in case of 10 minutes only, first 10 kilometers completed in 10 minutes only, then second 10 kilometers we completed in 30, and third 10 kilometers we completed in again 1 hour. There are different time of intervals in equal distances. Equal distances means the body traveled equal distances in unequal times of interval, as well as a body traveled equal. First half an hour we traveled 10 kilometers, second half an hour traveled 15 kilometers, third half an hour completed 5 kilometers. Like that means when the body in equal times of interval with unequal distances, a body traveled unequal distances in equal intervals of time, unequal distances in equal intervals of time. For example, just we know that when the body is traveling, when a body traveling B, C, D, A to D, the A to B, B to C, C to D is the unequal distances, means which is having total distances taken as this is 3 meters, this is 5 meters, this is 6 meters. Consider 3 meters, 5 meters, 6 meters. First 3 meters we should complete, the body completed in 1 minute, and second also 1 minute, and third also 1 minute, but the difference distances are different, means unequal distances completed in equal intervals of time, unequal distances completed in equal intervals of time. As well as we can say that if the distances are same, 3 meters, 3 meters, 3 meters. If in case of equal distances completed, first 3 meters completed in 2 minutes, second 3 minutes completed in 1 minute, and third 3 meters completed in 2 minutes, another 3 minutes also maybe take, means different times of interval with equal distances, either unequal distances in equal intervals of time, either equal distances in unequal intervals of time. That is called non-uniform speed. Non-uniform speed. In this case, if we write that if a particular if a body particle travels at a distance of s1, s2, s3, etc. within time t1, t2, t3 with the speed of v1, v2, v3, then the average will be s1 plus s2 plus s3 by, that means the total distances travelled by a particle by total time taken. The total distances are s1, s2, s3, so that's why s1 plus s2 plus s3 by the total time will be t1, t2, t3, so t1 plus t2 plus t3, that is equal to, but we know from the equation that is velocity is equal, means v is equal to d by t or s by t, distance means taken s by t is equal to v. In this case we can write that t is equal to s by v, t is equal to s by v. From that also we can write that t is equal, t1 is equal to s1 by v1, t2 is equal to s2 by v2, t3 is equal to s3 by v3, we can write that. From this formula, if in case of distances are equal, s1 is equal to s2 is equal to s, then we can write the equations also, means if in case of distance are equal, then the equation will be v average is equal to 2v1 v2 by v1 plus v2, means here the two velocities we are taking, the two distances, and as well as when the s1 is equal to s2 is equal to s, means the equal distances travelled by a particle, then we can say that the average velocity will be 2v1 v2 by v1 plus v2 will the equation. To find out the in problems, this is a very useful and important formula to do the numerical problem. Parameters of motion. In the parameters of motion we discussed about distance and displacement, as well as speed and velocity. In that velocity, in earlier video we discussed about speed and velocity also. The continuation for the velocity is whenever the average velocity and instantaneous velocity we discussed here, average speed and average velocity will be equal when the body is moving along a straight line without changing its direction, and instantaneous speed which is equal to instantaneous velocity in magnitude, because of whenever the body is moving along a straight line, then here we discussed about that when the body is moving along a straight line, distance is equal to displacement, distance and displacement will be both are equal, as well as here when the body is moving along a straight line, the average speed and average velocity is also equal in magnitude. In that case, instantaneous speed is also which is equal to in instantaneous velocity in magnitude. So here is that the instantaneous velocity in magnitude is equal to instantaneous speed. Some of the about the velocity and average speed, and about the some of the important points we are going to discuss. And also, if the particle moving along a straight line, means if the particle is moving along a straight line, without changing its direction, then its average velocity and average speed, which is both will be the equal. So in this case, when motion in a straight line, we will discuss the average speed and average velocity both are equal. We will consider as both are same. So in the motion in a straight line. So in this case, in other cases, the average velocity is always less than the average speed. So that's why we can get that average velocity by average speed, which is less than or is equal to 1. Means if the body is moving along a straight line, then at any point the velocity will be same, as well also instantaneous speed also same. The distance is equal to displacement. The average velocity and average speed also which will be equal whenever it is travelling straight. Then here in uniform motion means the body travels equal distances in equal intervals of time. In equal and intervals of time, the distance s is equal to velocity or speed into time. In this case, for circular motion, means when the body is moving along a circular motion, which is having this distance will be this, the circumference will be this circumference, total length of the circumference will be, means the particle travelled the circumference, Whenever it is in circular motion, the total distance which can be taken is 2 pi r. So that's why distance can be taken 2 pi r is equal to v into t. Because of here, this is the radius of the path which is having traveled the radius of the path when the body is in a circular motion, uniform circular motion. When the body is in uniform circular motion, then it's equal to 2 pi r is equal to vt, means the distance, this will be the distance travelled by a particle or an object, and this will be velocity or speed, and t be the time taken to complete this circle, time taken to complete this circle. Here is that we are going to know the what is average speed and average velocity in some cases when the particle is travelling in distances, some of the distances in a different times of interval. Means here we are going to know body covers the distances are s1, s2, s up to so on to sn distances in with a speed v1, v2, vn up to so on vn in time intervals t1, t2 up to so on to tn. We know that what is average speed? The average speed which is equal to the total distance travelled by total time taken to travel the distances is called average speed, that is s by t. Here is that the total distance travelled is s total s1, s2, s3. So that's why we are writing that s1 plus s2 plus s3 plus up to so on to sn by the total time taken. The time intervals are t1, t2, t3 up to so on to tn. So we are taking that t1 plus t2 plus t3 plus up to so on to tn. Then but we know that from the equation we have that s is equal to v into t, means when the body is in uniform motion. When the body is in uniform motion, then we can write that here t is equal to s by v. T is equal to s by v. In this relation we are writing that t1 is equal to, we can write that s1 by t1 plus s1 plus s2 plus up to so on to sn by s1 by v1 plus s2 by v2 plus s3 by v3 up to so on to sn by vn, sn by vn. In case of if the distances are equal, means whenever the body is in motion, whenever it is in uniform motion, the distances s1 is equal to s2 is equal to up to so on to sn is equal to s. Then if we consider that, then this total becomes a number of s. So here is that we are taking only two distances we are taking. If in case of two distances, if we take s1 plus s2, then here s1 plus s2 is equal to s. If we consider the body travelled from the s1, s2 be the distances with velocities v1, v2 in time intervals t1, t2. If we take 2, then we can get that is s1 plus s2 means 2s by these are all we are multiplying. Here is that s by v1 plus s by v2 by taking common outwards, the s will become, that is 1 by v1 plus 1 by v2, then s get cancelled by the LCM, doing LCM 2v1 v2 by here v1 plus v2 we can get, v1 plus v2 we can get whenever the s1 is equal to s2 is equal to s. If in case of the body covers different distances with different speeds, we can get that 2v1 v2 by v1 plus v2. In case of 3 displacements we can get that is s1, this is of 2 displacements. If in case of s1 is equal to, s2 is equal to, s3 is equal to s, then we can get from the 3 displacements is there, then we can get that 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1 with the average speed, with the average speed. Here is that we can get the total values, further values, continuation values whenever we substitute the values, where this is the average speed, this is the average speed whenever the different distances with the different speeds. In this case of if the distances are equal, then this will be the equation for 3 distances taken, then 3v1 v2 v3 by v1 plus v2, v1 v2 plus v2 v3 plus v3 v1 be the equation. In this case also we can find out that for the different speeds in different times of interval, different speeds in a different times of interval, we can write that different speeds in different intervals of time, different time time interval. Then we can get already, we know that average speed. The average speed will be average speed. The average speed V average is equal to, we know the formula, that is S by T. From that relation already a body covers S1, S2, S up to so on. Sn is this considered this equation. This is the one case and this is the second case. Consider this is second case. In that case we know that the total displacements are S1 plus S2 plus up to so on to Sn by time intervals are T1 plus T2 plus up to so on to Tn, up to so on to Tn. In case of, if in the different speeds in different times of interval, we can get the different speeds. We know that from the formula V is equal to S by T. From the relation S is equal to Vt. S is equal to Vt. From this case S1 is equal to V1 T1 and S2 is equal to V2 T2. From that as well as we can write that V1 T1 plus V2 T2 plus up to so on to Vn Tn by here T1 plus T2 plus T3 plus up to so on to Tn be the relation whenever the body moving with different speeds in a different intervals of time. Then if in case of the in equal intervals of time, means whenever the body is traveling in equal intervals of time in uniform motion. If the body is in uniform motion, it covers equal distances in equal intervals of time. Then in equal intervals of time in uniform motion, T1 is equal to T2 is equal to up to so on to is equal to T is equal to T. If we consider T, then if in case of we will substitute T, then we can get that V average is equal to here the T of V1 plus V2 plus up to so on to Vn by here is also we can get that number of tens T up to so on to n. So that's why a number of T's means the number of time intervals. So that's why number of time intervals, then T get cancelled. From this relation we can get that V1 plus V2 plus up to so on to Vn by n, means V average is equal to, we can get that V average is equal to, we can get that the sum of the, this is called as the arithmetic mean of individual speeds. This is also called this is the, it is the arithmetic mean of individual speeds. This is the arithmetic mean of it is also known as the arithmetic means of V average is equal to V1 plus V2 plus up to so on to plus Vn by n. This is the arithmetic mean. Arithmetic mean of individual speeds. Once again, when the velocity, average velocity and instantaneous velocity will be average velocity, we discussed about it, and the average velocity which is equal to average speed whenever body is moving along a straight line without changing its direction. Until it's changing its direction, the average velocity is equal to the average speed. In other cases, average velocity is less than the average speed always. So that's why we wrote the earlier that average velocity by average speed less than or is equal to 1. From that relation, if the body is moving, the distances are S1, S2, S3, S up to so on to Sn, then with velocities, speeds V1, V2, V3 up to so on to Vn, in time interval T1, T2, T3 up to so on to Tn, number of times, number of distances, number of with number of velocities. Then if the body covers different distances with different speeds, then average speed is equal to, we know that the formula, the total distance travelled by total time taken. The total distance travelled by total time taken will be taken as S by T. So here is the distances which are taking that S1, S2, S3. So that's why we are substituting that we are summing the S is equal to S1 plus S2 plus S3 up to so on to Sn is the total distances travelled by the body, and the time taken by the body is T1 plus T2 plus T3 up to so on to Tn. But from the relation we know that, from the relation S is equal to Vt, from that relation we know that T is equal to S by V. T is equal to S by V. From the relation T1 is equal to S1 by V1 and T2 is equal to S2 by V2. Like that we are substituting in the instead of T1 we are writing S1 by V1 plus S2 by V2 up to so on to Sn. If in case of the uniform motion, equal distances travelled by a body in uniform motion. In uniform motion, equal distances travelled by a body. Then so that's why we are considering that S1 is equal to S2 is equal to S. In that case, the S, whenever we substitute that values, the S plus whenever we are only taking the two measurements only here, so S1 plus S2 then is equal to S, then we can get that S1 plus S2 the 2S by whenever we take the S outside, then we can get 1 by V1 plus 1 by V2. So S get cancelled, we will get that by doing LCM 1 by V1 plus 1 by V2. By doing LCM we can get a 2 V1 V2 by V1 plus V2, like 2 by V2 plus V1 by V1 V2, like that from the relation we can get a 2 V1 V2 by V1 plus V2. If in case of the three distances we are taking that the S1 plus S2, S1 is equal to S2 is equal to S3 is equal to S, then the formula will be 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1 with the equation. If the body is moving with different speeds in different interval of time of interval, then we can get that we know the formula of average speed will be V average is equal to S by T. From that relation, the sum of the individual distances, that is S1 plus S2 plus up to so on to Sn, and the time intervals are T1 plus T2 plus up to so on to Tn. With that we know the formula, that is V is equal to S by T. From that relation we are writing that S1 is equal to V1 T1 and S2 is equal to V2 T2. From that relation we are substituting V1 T1 plus V2 T2 plus V2 up to so on to Vn Tn instead of S1 S2. Then from that relation, if in case of in uniform motion the body taken time equal time of intervals during its motion, so that's why that T1 is equal to T2 is equal to up to so on to is equal to Tn is equal to T. By substituting the values we can get the T outside because of all the terms having the same component same T. So T get cancelled. Here is the number of T's are added, so that's why N into T. T get cancelled. Finally we get the relation V average is equal to V1 plus V2 plus up to so on to Vn by N be the average velocity whenever a body is moving different speeds in a different intervals of time. This is the relation. If in case a body is moving different distances with different speeds, then we can get the value 2 V1 V2 by V1 plus V2 be the relation. This is about average speed and velocity. Next we are going to know what is the change of velocity. Means whenever the velocity is increasing means acceleration, or if the velocity is decreasing then it is called as retardation or deceleration. The parameters of motion means when the body is in motion, then what are the parameters are involved during its motion, means displacement, distance, velocity, speed, acceleration, retardation, like that. So in also we did that we learnt about that what is uniform motion. Uniform motion means when the body is travelled in equal distances in equal intervals of time. Means when a body is moving first second, when a body travelled, time taken by the travel to the 30 minutes, then at the first minute body travelled for 10 meters, then the second minute also it has to take in there another 10 meters only. So here is that when the body is travelled equal distances in equal intervals of time is called as a uniform motion. And also uniform velocity. Uniform velocity means the body is travelled equal displacements in equal intervals of time is called as a uniform velocity. Like that, here the uniform acceleration is also we'll learn about it. What is meant by the uniform acceleration? Uniform acceleration means body is already in the motion, which is having that small velocity. It's having that initial velocity, all some of the velocities it have. So the body is increases its velocity equally in equal intervals of time. Its velocity goes on increasing. Means at the first second if it is increased by the 10 meter per second, and another second also it has to increase at the 10 meter per second only. Means it is increment, not maintaining the same velocity. Means if in case of if it is maintaining same velocity, that will be uniform velocity, then acceleration will be 0. If the body is in uniform velocity, then acceleration will be 0. So that here uniform acceleration means that body must be increasing its velocity in equal intervals of time is called a uniform acceleration. By using this, when the kinematical equations, what are the kinematical equations? Means when the body is traveling, to find out the velocity or acceleration or time, displacement. Earlier we have discussed about the parameters. To know the values of parameters, somehow here the 4 equations of kinematical equations of motion is there. Those are, let's see what are they. So first one is V is equal to U plus AT. This is the kinematical equation. Kinematical equation means this is the relation between the velocity time relation. It is also called as velocity time relation. It is also called as a velocity time relation. Velocity time relation. This one is the velocity time relation, because of it is between the velocity and a time relation. The next one is second one is S is equal to ut plus half at square. Ut plus of at square means here is the S means displacement. This is the relation is also called as a displacement time. Displacement time relation. Displacement time relation. It is also called as a displacement time relation. Here the next one is third relation will be V square minus U square is equal to 2AS. This relation is also called as velocity displacement relation. Velocity displacement relation. Velocity displacement relation. By using this velocity we can find out that retardation and acceleration, as well as we can find out the displacement, we can find out the values, initial value, initial velocity or final velocity, like that. So the last one, the next one is fourth equation is nth second. That means the displacement of a particle at some of the nth second, the instantaneous displacement. If taken that when the nth second or nth time, then Sn is equal to U plus A of n minus 1 by 2. Or this is also can be written as this relation is also can be written as Sn is equal to U plus A by 2 into n minus 1. These are the kinematical equations of motion. And also another relation is also there that is useful for the stopping distance. Stopping distance means here we can see that stopping distance means the relation between the time and the displacement. That is S is equal to V plus U by 2 into T. V plus U by 2 into T. This is the relation for the stopping distance. Means the relation between the displacement and time, as well as we can find out that acceleration is also. So by using this relation we can find out, we can do the problems. Then these are the relations are called kinematical equations of motion. So let's see how prove it. Let's see the kinematical equations. We will verify that one and we do the proof. The first one is a velocity time relation. Velocity time relation. The velocity time relation will be, the first one is a velocity time relation. That is a V is equal to U plus AT. V is equal to U plus AT. This is the velocity time relation, we can say that. Then by using the graphical treatment, this is the graphical method. Let's see, listen carefully. The values which can be taken, time is taken in x-axis, along x-axis, the time, and velocity along y-axis. This is a y-axis and it is a x-axis. So here I already mentioned that is uniform acceleration. Uniform acceleration. What is meant by the uniform acceleration? That consider a particle is already having some of the velocity, initial velocity u, means this is u. A particle is having a initial velocity u. After traveling some distance in time t, consider, first of all, consider a body of its initial velocity u and traveled in a time t, means some of the travel, it is traveled some of the time t. According to this is a t. Here its a final velocity will be v, means whenever it reaches this one, then the total velocity will be v, the final velocity will be v. So here is a, consider it's a b. I am drawing a imaginary line which is perpendicular to the BCD. The body having that initial velocity u with uniform acceleration, body will ever traveling in uniform acceleration. Uniform acceleration means that body is already have some of the velocity u, its initial velocity, and traveled with the time. Uniform acceleration means with the uniform time the body is also traveled, the velocity is also increasing with the time. Velocity is increasing with the time. So that's why the time is after time t seconds, its initial final velocity will be v. So here is that this is the u and the total will be v because of velocity time graph. We are taking here that the velocity time graph. So that's why here the total can be considered as a, this is considered as a v. So from that we know that this is a u because of which is parallel to this one. So that's why this will be u, and finally this will become v minus u because of the total will be v and velocity v, and whenever this value will be u, then we can take that this value becomes a v minus u in time or t. This is also parallel to this one, so that's why this value will be u, and which is making an angle theta with the horizontal x-axis, with the horizontal line which is parallel to the x-axis. So this is the graph which is useful to determine all the kinematical equations of motion. So concentrate on one another. Whenever the body is moving with uniform acceleration, means already body is having some velocity, and with that time the velocity is increasing, so it reaches to b, then in time t. The body reaches to b in time t. So that's why we are drawing the imaginary line perpendicular to this a b d. The means the total body displacement which is under the AB curve, AB line, under with the x-axis will be the total displacement will becomes this one a b c d o a. That will be the total displacement of the body. Then here let's see what is velocity time relation. We can find out that from the slope, means from the slope AB, from slope AB we can write that from the triangle ABC, from the triangle ABC, from the triangle we can write that it is tangential to the, it is tangentially tangential line. So that's why we can take that tan theta which is equal to, tan theta is equal to, we know that tan theta is equal to opposite by adjacent. Then what is opposite? BC by what is adjacent? AC. So AC. But we know that what is BC? V minus u. And what is AC? Means T, which is, we know that the tan theta is, the angle will be the very small which can be written. So when we know that V minus u by T is equal to, this is the definition of acceleration, means the rate of change of velocity, means the velocity changes with the time, the change in velocity with the time. So that's why we can write that V minus u by T is equal to A. V minus u by T is equal to A. From this relation we can write that V minus u is equal to AT. V minus u is equal to AT. From that V is equal to, whenever the u taken to this side, then it will become minus u becomes plus u. V is equal to u plus AT. This is the relation between velocity and time relation. This is velocity and time relation, which can be kinematical equations, the first kinematical equations of motion. Once again, let's see. Whenever the body is moving with uniform acceleration, means it is already having some initial velocity, that is a u. Whenever it travels after t seconds or t time, then its final velocity becomes v. Means the final velocity will be v. So that's why we are taking that, we are drawing an imaginary line to the perpendicular x-axis and y-axis to know the position, and from the point of A, then the distance travelled by this is the total value, then we can get then the final velocity minus initial velocity, the distances we have taken by using the graphical method. From the relation we can write that is tangential, so that's why we are taking tan theta, that is equal to BC by AC. Then from that v minus u by t is equal to, we know that is acceleration, means the rate of change of velocity is called as acceleration. So from that acceleration we can take that whenever taken to the t this side, then it will multiply with the a. So v minus u is equal to at, then v is equal to minus u taken to this side, then it will becomes minus u becomes plus u. So v is equal to u plus at. This is the equation for first kinematical equation. So next, the second kinematical equation will be the second one. The second one is a displacement time relation. Displacement time relation, that is S is equal to ut plus half at square. This is the most important relation in public examination. We get mostly we can get for 4 marks. This is the most important relation in the public examination. He asked for x is equal to ut plus half gt square, ut plus half gt square or half at square also, because of in case of acceleration due to gravity, it will not act. Whenever the body is moving vertically, then only acceleration due to gravity is act on the body. Whenever the body is moving horizontally, then the body will be traveled acceleration. So that's why we can take that at square or gt square, both will be same whenever the body is moving horizontally, because of at every point the body acceleration due to gravity is acting same on the body. So here it is that we can ask, they can ask like this also, instead of u you can ask v naught t also. X is equal to v naught t. V naught t means v naught means here the velocity at 0 time. The velocity at 0 time, x is equal to v naught t plus half at square. X is equal to v naught t plus half at square, or s is equal to ut plus half at square also. You can ask for 4 marks. The very important question for the academy, intermediate public examination. So first of all, by taking this, to know that this is the time displacement time relation. So when the body is travelled after t seconds, the body reached to the point B, then the total relation, the total displacement of a body, this is under the AB line, under the AB tangent line, which is drawn perpendicular to the x-axis. Under the, from the x-axis line, this will be the total displacement, that is S. Means the S be the displacement, total displacement. S be the total displacement. S be the total displacement. We can say that we can divide this to, for our easy convenience calculation. For easy calculation, we can divide this. We can draw the perpendicular. We already have. Here is one triangle is there, and another rectangle is there. So if we add the area of triangle and area of rectangle, then we can get the total displacement. The total displacement we can get. So that's the S is the total displacement. We have taken that. That is S is equal to area of triangle plus area of rectangle. Area of rectangle. So area of triangle plus area of rectangle. We know the formula, mathematical formula of area of triangle and area of rectangle. What is area of triangle? Area of triangle means half into length into breadth. So that's why S is equal to, triangle means here ABC, triangle ABC. Here rectangle means OAB, OACD. OACD. So for the easy calculation, S is equal to triangle means area of triangle means half into length. What is the length? This will be the AC into breadth means V minus U. V minus means here the AC, right? AC into BC plus the area of rectangle, length into breadth means OD into CD. OD into CD. So already total values we have, so that's why we are substituting the values. Then first of all I am writing OD into CD, that is OD means that time T into CD means the value will be U into U plus next half AC means T into BC means V minus U. So S is equal to UT plus half. V minus U means we know that from the relation here V minus U is equal to AT from the kinematical equation, since here we are writing the T into AT, since V minus U is equal to AT. Because of V minus U is equal to AT, we are writing that half T into AT. So from the relation we can write that S is equal to UT plus half AT into T, AT square, half AT square. This is the second equation for the kinematical equation. This is the first one and this is the second equation for kinematical equations. Once again, to know the displacement when the body is traveled with uniform acceleration, which is having that initial velocity u, after t time, then the final velocity will be v, then the curved line will be that it is tangential line. So that's why AB, under the AB area will be the total displacement of the body. So here it is that when the AB taken the perpendicular drawn on the x-axis, then here the total area means here one rectangle is there, one triangle is there. So that's why the area of rectangle and area of triangle we can, if we sum the both, then we can get the total displacement. From the displacement, area of triangle or area of rectangle, which can be add like anything. So S is equal to 1 by 2 into area of triangle is half into length into breadth, so that's why height into breadth, so that's why length into height, then half into AC and half into BC plus OD into CD means here the length into breadth, the length into breadth is CD into OD into CD. From that also we can write the T into U plus half T into V minus U. We are by substituting these values in the equation, then we can get that S is equal to UT plus half T into, we know that V minus U is equal to AT from the relation, from the initial relation V minus U is equal to AT. By substituting that value we can get that S is equal to UT plus half AT square. This is the relation for displacement time relation, the second equation for the kinematical equation. So this is the very important formula to find out the problems by the time, to find the time and also to find the displacement. And according to the intermediate public examination, this is the very important from this motion in a straight line lesson to give, mostly we can get this problem like x is equal to v naught t plus half a t square, like that. If in case of the displacement is overall that this is the displacement which happened, so that's why we can say that here according to the x axis, so that's why displacement s is equal to, you can write that x. Then also initial velocity we know that u is equal to velocity at time 0, that is v naught. By substituting these values we can write that when s is equal to x, then s is equal to x and u is equal to v naught, then also we can write that x is equal to v naught t plus half a t square, also we can write that. This is also equation for displacement time relation. This is about the first and second kinematical equations of motion. Let's see the third kinematical equations of motion by the graphical method, means by using the graph we derived an equations that is in earlier video we discussed about v is equal to u plus at and s is equal to ut plus half at square. These are the kinematical equations we have proved. So next we are going to prove this v square minus u square is equal to 2as, that is the third kinematical equation of motion. So in case of v square minus u square is equal to 2as means this is relation between the velocity and displacement relation. Velocity and displacement relation. Velocity displacement relation. So from this relation we can write that here we know v is equal to u plus at. That is the first kinematical equations of motion. From that equation we can write v minus u is equal to at. By taking this u into this side, then the plus u becomes a negative u, that is v minus u is equal to 80. Consider this equation number 1. And the displacement s is equal to v plus u by 2 into t. V plus u by 2 into t means here we can write that is average velocity, that is equal to s by t. Then from that equation s is equal to v plus u by 2 into t. So s is equal to v plus u by 2t into, we can write this equation whenever 2 taken this side, that will multiply with s. So v plus u is equal to 2s, and whenever the t taken to this side to the is equal, then it will become a denominator, that is a v plus u is equal to 2s by t. This is equation number 2. From that relation, from the two relations, from equations 1 and 2, from equations 1 and 2, from the relations equation and 1 and 2 we can write that v minus u into v plus u, v minus u into v plus u, that is equal to, we can write at into, this is 2s by t, 2s by t. So from this is in case of a minus b into a plus b, in the form of a minus b into a plus b. So from the mathematical formula we can write that, we know that a minus b into a plus b is equal to a square minus b square. So from that, in the a, b square is there, and b square means u square. Then by the cancelling the denominator and numerator having tt, so that's why the t both will be cancelled. We can get that 2as. This is the equation for kinematical equations of motion, third equation. By using this equation we can write that here the v square minus u square is equal to 2s. From this relation several equations can be derived in the form of, by changing the equation we can get the value for acceleration as well as displacement, like that. So from this relation we can get. So here another one, once again we know that v is equal to u plus at. From this relation we are writing that u is taken to this side, then becomes a v minus u is equal to at. Then already we know that s is equal to v plus u by 2 into t, that is the equation for the displacement. Then s is equal to v plus u by 2 into t. From this relation we can write that by taking to this side it will be multiplied, and t taken to this side, numerator in this side of this is numerator. So whenever it taken to this side it will becomes a denominator. Then v plus u is equal to 2s by t, that is considered as equation number 2. From these two equations we are multiplying two equations, v minus u into v plus u, v minus u into v plus u, that is equal to at into 2s by t, at into 2s by t. T get cancelled because of t is at the numerator and here the denominator, both will be cancelled. From this 2s into a to as. This is the relation, the third kinematical equations of motion. The next one is the fourth one, that is Sn is equal to u plus a of n minus 1 by 2. The fourth equation. There is a fourth equation. That fourth equation can be considered as when a body is moving. Consider a body is started from O with initial velocity u, and after n minus 2 seconds, that point it reached to point A, and whenever it reached to point B, it n minus 1 seconds, and after traveling some distance c, it n seconds. Means the time taken to travel from initial velocity u with u is started from O to A is n minus 2 seconds, and from the time taken to A to B is n minus 1 seconds, and from B to C, that is n seconds. So from the dot we want to know this, the relation Sn means the distance at nth second. The distance at nth second is BC. The distance at nth second is BC. Just write that after reaching a initial velocity is u. After n minus 2 seconds, object reached or body reached body at A. At n minus 1 seconds, body at B. At n seconds, body at C. This is the whenever the body started from certain travel at n seconds to C. That is at nth second means the time it has taken that B to C be the nth second. We just want to know that the nth second, the distance travelled by an object at nth second. So that is BC is the distance travelled by object or body in a n second. At nth second, and at nth second the distance travelled by a body. So that is BC is equal to, from this point to this point the time has taken is n minus 1, and this one is n, total distance travelled n seconds. So if we deducted from this the total from the distance to the this one distance, we can get the BC, right? So to know the distance between BC from the total distance, if we deduct this one, the total distance taken the time is n seconds. The total distance taken the time is n seconds. So that's why that is we are deducting that. So then we can get that the distance at n minus 1 second, distance travelled in n seconds minus distance travelled in n minus 1 seconds. That means here don't be confused, the BC is the distance travelled by an object at nth second. Then the distance travelled in n seconds be the total distance. So that's why we are writing that BC is equal to distance travelled in n seconds minus distance travelled in n minus 1 second. Distance travelled by a body in n seconds from this place to the C, that is OC minus the distance is OB. From this relation we can write that we have the equation to find out the distances, that is S is equal to ut plus half at square. So from that S is equal to ut plus half at square, we can measure the distances. That is BC. That is BC is the distance travelled at nth second. That is BC is equal to, that is OC means the distance travelled from O to B. O to C is nth second. So that's why we are substituting this. OC is equal to the distance travelled in n seconds is U. T means that is n seconds time plus of A n square, and OB means U of n minus 1 plus half A into n minus 1 whole square. So from this relation we are substituting the values in the equation. Then that is BC is equal to UN plus half AN square minus of U of n minus 1 plus half A n minus 1 whole square. So we are substituting, this minus symbol indicates that whenever we are multiplying inside, then we can get UN plus half AN square minus of UN minus U plus we are multiplying this half a. It is in case of a minus b whole square in the formula, in the form of a minus b whole square. So we are writing that n square plus 2n minus plus n square minus 2n plus 1. So we are multiplying total minus into inside, then un plus half a n square minus un minus into minus plus u minus into plus minus 1 by 2 a n square. Half a is also multiplying inside, then minus into plus minus, so minus a n square, then minus half a into 2n, that is plus half a n, and minus into plus minus half a, minus half a. Half a is also multiplied inside and minus symbol is also multiplied inside. So from this relation we can write that here we have that half a n square of half a 2n is there, half a 2n is there, so 2 get cancelled, then here minus un is there, plus un is there, and half a n square minus half a n square get cancelled. So the remaining the remaining will be this. Here BC is equal to u minus 1 by 2a plus an, or we can write that, also we can write that u plus an minus 1 by 2a. Here is also we can write that formula. So from that formula BC means the total distance, means the distance travelled by a body at nth second. So that's why that is a Sn, the distance travelled by at nth second, Sn is equal to u plus a is both are the same in this two terms. So that's why we are taking common a of n minus 1 by 2. This is the relation. When a body is travelled to certain distance, then at the nth second, at a particular of time at the nth second, then to find out the distance of a particle, then we will use this formula. This formula also can be written as a Sn is equal to u plus of a by 2 into 2n minus 1. This is also formula for at nth second. These are the kinematical equations of motion, the proofs of the equations of motion by using the graphical method. Kinematical equations of motion of a body with a uniform acceleration, When a body started with initial velocity u, it reached at n minus 2 seconds at point A, and it reached to n minus 1 seconds at B, and it reached at n second will be C. So with initial velocity u, n minus 2 seconds at body A, and after n minus 1 seconds reached B, and at n seconds reached to C. But we want to know this to find out to verify this formula, to prove that formula. Sn means at nth second distance, the body travelled at nth second distance is BC. At nth second, this is the n minus 1 second. After n minus 1 will be the nth. So that's why the BC be the at nth second distance. So that's why here BC is the distance travelled by an object at nth second. So from that BC is equal to the total distance travelled by an object minus the total distance travelled in n minus 1 seconds. That will be distance travelled in n seconds minus the distance travelled in n minus 1 seconds. That is OC minus OB. That is BC is equal to OC minus OB. From this relation OC is equal to, we know that UN plus half n square, because of instead of t we are writing that we are taking the number of times, right? Time taken as in n. So that's why we are mentioning that is t is equal to n in this place at OC, and here t is equal to n minus 1. So we are substituting these two equations in this equation. So here un plus half a n square minus u of o, we are substituting the same formulas in this case by applying inside. This is in the form of a minus b whole square. We are expanding, then we can get that. Then minus and half a is multiplied inside. We can get that equations. Here 2 is common, so that's why it cancelled. Remaining as a n and un plus un minus un get cancelled. Half a n square plus half a n square minus half a n square get cancelled. That remaining terms are u plus half a u plus an minus of a u plus an minus of a, that is BC be the distance travelled by an object at nth second. So that's why Sn is equal to u plus a of o n minus 1 by 2 be the equation that has a hence that is a proved, hence proved. This is also relation between the displacement and velocity. V square minus u square is equal to 2a is also, hence in earlier video we discussed about the kinematical equations of motion derivations by using the graphical method. By using the graph we derived an equations, that is equation of motion is the equations of motion are v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as, and Sn is equal to u plus a of n minus 1 by 2, and s is equal to v plus u by 2 into t. This will be the stopping distance. So here we are going to know that by using the calculus method, what are the derivations of relations, means derivations of relation. This v is equal to u plus at, first one, that is v is equal to u plus at, means the velocity time relation, velocity time relation. By using the calculus method means by doing the integration we can find out that in this relation this is a easy process. That is we know that the acceleration, definition of acceleration. The definition of acceleration is acceleration a is equal to change in velocity by time, means the rate of change of velocity. The rate of change of velocity is called acceleration. So from this formula we can write that the change in velocity means the dv, the time has changed from initial 0 to t. So that's why the change in time is t. Means when a body is moving with initial velocity u, means that is at time t is equal to 0. At a time t is equal to 0, the body velocity must be u, and its final velocity means after traveling some of the distance, the velocity will be u in time t. In t seconds the body is traveled some distance, then that will be the final velocity, that is v. So acceleration a is equal to the rate of change of velocity, that is change in velocity by time, that is dv by dt. So a is equal to dv by dt, is it right? Right. So then we are multiplying that, so dv is equal to a into dt. dv is equal to a into dt. We are measuring that the dv is equal to a into dt, means the velocity changed from u to v, and time changed from 0 to t. Time has changed. So acceleration is the body is moving with uniform acceleration. Uniform acceleration means the acceleration can be constant. If we do the integrate, then that will become 0. So that can't integrate it. So that's why integrating on both sides means dv is equal to a dt. Integrating on both sides, simply integrating on both sides. Integrating on both sides, then we can get that the velocity changed from u to v, between the limits u and v, that change in velocity and acceleration can't be integrated. So that's why the time changed from 0 to t dt. So whenever the integral constant, the integral dx is equal to we know that x. Here that integral dv is equal to v between the limits u to v, that is equal to, and a of here is also integral dt means t between the limits 0 to t. So whenever, if in case of x between the limits y to z, x between the limits y to z, then if we multiply, if we substituted, there is y to z, like limits are substituting in the term, then like this. First of all we should enter the upper limit, that is here, that is z in this x. So z minus after that lower y, like this. So here is also we are substituting, here we are substituting this First of all, we are substituting upper limit, that is v minus then u, that is equal to a of, here first upper limit is t minus, after that 0. Then we can get v minus u is equal to a into t. From this relation, v is equal to u plus at. This is the equation kinematical. This is the equation for kinematical equations of motion by using the calculus method. This is the integral formula. Don't be confused. So whenever we do the integration of the change in velocity without anything, the delta x means like this. We should do like this. So another one. The next one is second one is s is equal to ut plus half at square. That means the relation between displacement and time relation means displacement time relation. Here we write displacement time relation. Here displacement to time relation, that is s is equal to ut plus half at square. The second one ut plus half at square. Then so here we know that the velocity v is equal to the rate of change of displacement. So that's why we can write that the velocity v is equal to ds by dt also we can write. So from this relation ds is equal to v into dt. But we know that what is v? V is equal to u plus at. From this relation we can write the ds, the displacement which has happened between the limits 0 to s, 0 position time t is equal to 0, rest to body is in motion. So the displacement will be from the 0 to s will be the displacement, velocity will be from u to v, initial velocity, final velocity, initial displacement, final displacement, then time 0 to t. So we are measuring that ds is equal to u plus at into dt. dt is multiplying inside, then we can get that ds is equal to u into dt plus a into t dt. So here another formula of mathematical formula is also there, that is integral x power n is equal to x power n plus 1 by n plus 1. Integral x power n is equal to x power n plus 1 by n plus 1, that is the mathematical calculus formula. So we should remember that one. Both sides, integrating on both sides. Integrating on both sides. So whenever integrated, the displacement will be 0 to s. So that's why 0 to s ds, that is equal to u into dt. U is also initial velocity at time t is equal to 0. That's why we are writing that. That is u integral dt between the limits 0 to t plus a is the uniform acceleration. So that's why we are also taking that side. That can't be integrated. That is time taken, so 0 to t. The time is changing, so that's why time writing. This is the form, that is the integral x power n dx is equal to x power n plus 1 by n plus 1. This is the formula we have to apply whenever is in this form. There is nothing is there, that is then can be considered there is 1. So here we are substituting this. Here s between the limits 0 to s, that is equal to here u into t between the limits 0 to t. Nothing is there, so that's why like this. Here we did the calculation plus a into, in this x position there is a t, in this at nth there is a 1. So t power 1 plus 1 like that. T power 1 plus 1 means t square by 2 from 0 to t. We are applying the limits. If we apply the upper limit s minus 0, yes, that is equal to u into t. T minus 0 will be t, so that's why ut plus 1 by 2 taken outside, then 1 by 2 a t. If we apply t square minus 0 square, t square. So this is the relation. By applied the limits, then we can get s is equal to ut plus half at square. This is the relation by using the calculus method. The third one is v square minus u square is equal to 2as. V square minus u square is equal to 2as. So we know that formula of acceleration A is equal to dv by dt, means the rate of change of velocity, that is acceleration, is equal to dv by dt. So I am writing that A is equal to dv by multiplying and dividing with ds. 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 Then we can get that A is equal to dv by ds into ds by dt. Can we write like this? By cancelling each other the ds, then we can get the same thing dv by dt. By cancelling ds, then we can get the same thing. A is equal to dv by dt. So here A is equal to dv by ds. In this case, we know that what is ds by dt? ds by dt means here we wrote that the rate of change of displacement is called velocity. So we are measuring that here dv by ds into v, because of since v is equal to ds by dt. V is equal to ds by dt. So we are measuring this one, and same thing, both are integrating on both sides. Then dv is equal to ads multiplying, then integrating on both sides. Integrating on both sides. Wherever we integrate on both sides, then here velocity will be from u to v, that is dv. Here A is the uniform velocity. The displacement will be from 0 to s. So that's why 0 to s ds. So here we are measuring this dv by vs into v into dv. Here v is there, so here v is there. By integrating on this, already we know the formula x power n dx is equal to x power n plus 1 by n plus 1. Like that also we are measuring v power 1 plus 1 by 1 plus 1, means v square by 2. V square by 2 between the limits u to v, that is equal to a into, here is the displacement s between the limits 0 to s. So by applying limits, first of all we are applying v, means v square minus u square, means v square minus u square by 2, that is equal to a into s, means upper limit we are applied s and lower limit will be 0. S minus 0 will be s. So by this equation, whenever the 2 taken to this side, then v square minus u square is equal to 2as. This is the relation for kinematical equations of motion by using the calculus method, the third equation of a motion. Once again, by acceleration A is equal to dv by dt, multiplying and dividing with ds. Whenever we determine the rate of change of velocity is called acceleration, multiplying this equation with the ds, multiplying and dividing with ds, then we can get that dv by ds into ds by dt. But we know that the velocity is equal to the rate of change of displacement. The rate of change of displacement is called velocity. So dv by ds into v, acceleration A is equal to dv by ds. From this relation we can write that dv by ds into v. So from this relation we can write that by doing the cross multiplying, ds came to this side, then v into dv is equal to a into ds. So both sides integrating. Whenever integrated between the limits, velocity will be uv. So between the limits u and v, v dv, integral v dv, and a in between the limits 0 to s will be the ds. Then by doing integration by using the formula integral x power n dx is equal to x power n plus 1 by n plus 1, that will becomes v square by 2 between the limits u and v, that is equal to a into s. Integral ds means s between the limits 0 to s. So by applying the limits, then we can get that first of all we should apply the substitute the upper limit, after that the lower limit. First upper limit minus lower limit, that is v. V means v square, minus lower limit will be u, so that's why u square. V square minus u square by 2 as is we can apply, is equal to a into s. First of all upper limit s and the lower limit will be 0, so s minus 0 will be s, so as. V square minus u square by 2 is equal to as. So from this relation, whenever the 2 taken to this side, that will be multiplied, so that v square minus u square is equal to 2as. That is the third kinematical equation. Here the first kinematical equation will be this: acceleration, the change in velocity by time, that is dv by dt, that is equal to a. So by doing the cross multiplication, then we can get that dv is equal to a dt. So from dv is equal to a dt, integrating on both sides between the limits when the velocity is changed from the u to v and the time with the time in 0 to t, the displacement 0 to s. Then by applying a integration, then we can get that integral x dx means like that, integral dv means v between the limits u and v. If we applied the limits, first of all we should apply the upper limit minus lower limit. So v minus u, that is equal to a into integral dt means t between the limits 0 to t. So v minus u is equal to a of t minus 0. First of all we should apply upper limit, after that lower limit, t minus 0. So v minus u is equal to a into t, at. This is the first equation of motion. The second one is s is equal to ut plus half it squared, the relation between the displacement and the time. So from the velocity, v is equal to ds by dt, means the rate of change of displacement is called a velocity. From this relation, by doing the cross multiplication, ds is equal to v into dt. But we know that from the first kinematical equation of motion, v is equal to u plus at. In this v, instead of v, we are writing that v is equal to u plus at. We know that we are applying that one. ds is equal to u plus at into dt, we are applying inside, then u dt plus at dt, integrating on both sides. Then as usual by the calculation, here the t power 1, if there is nothing is there, we will consider it's a 1. So that's why the t power 1 means t power 1 plus 1 by 1 plus 1, from like this t square by 2, as it is integral dt means t between the limits 0 to t, integral ds means s between the limits 0 to s is the displacement limit. By applying the limits, applying s minus 0 is equal to u, t means you apply the t minus 0, that is ut plus of a, half taken outside, then of a, t square, upper limit will be t, lower limit will be 0, t square minus 0 square, so that means say t square. So s is equal to ut plus half a t square be the relation, kinematical equation of motion. These three relations are kinematical equations of motion as derived by using the acceleration due to gravity. Acceleration due to gravity means when a body is falling freely from certain height due to the gravitational attraction, that body increases its velocity from the starting point to the whenever it reaches to the ground. Due to that, change in velocity is acceleration. Due to the gravitational attraction, the acceleration of a freely falling body due to gravitational attraction is called acceleration due to gravity. Means when a body is falling freely from certain height, when a body is falling freely from certain height due to the gravitational effect, gravitational attraction, that is called acceleration. In that situation, the body possesses acceleration, velocity is increasing. So that's why that acceleration is called acceleration due to gravity, means acceleration due to the gravitational attraction, the velocity is increasing whenever the body is falling freely from certain height. So that's why it is called as acceleration due to gravity, and it is denoted with the small g, and its value will be in centimeters radius 980 centimeter per second square, and as well as in meter per second 9.8 meter per second square. In feet we can write that is 32 feet per second square, 32 feet per second square. These are all the values of acceleration due to gravity whenever the body is falling freely It increases its velocity, means it possesses acceleration. Whenever the body is falling from certain height, the acceleration due to the gravitational attraction, the acceleration of a freely falling body due to the gravitational attraction is called acceleration due to gravity. In case of, we have derived the equations of motion. In equations of motion, these are when the body is falling freely from certain, body is in motion from certain height, it is moving vertically downwards due to the gravitational earth, due to the gravitational attraction of earth, then that fall is called as a free fall. Whenever the body is moving from certain height due to the gravitational attraction, that fall is called as a free fall. Due to that one, the acceleration will be for freely fall, acceleration due to gravity will be positive, because of it is under the gravitational effect the body is acting. So that's why it is having that some of the velocity is adding due to the gravitational attraction. That body possesses the g is equal to 9.8 meter per second square, plus the additional velocity will be added to that one. So that's why it is a is equal to plus g, acceleration due to gravity whenever the body is freely falling, that is will be positive. In case of equations of motion for freely falling bodies, we know that what is the equations of motion. V is equal to u plus at, and second one is s is equal to ut plus half at square, and the third one is v square minus u square is equal to 2as. These are the kinematical equations of motion. So that in the kinematical equations of motion, we are going to substitute whenever the body is freely falling, means it is from the certain height is having and it is freely falling. So here it is that whenever it is falling from certain, if we consider that the height will be s, then s is equal to the displacement of a body will be s is equal to h, and it is under gravitational effect, the body is moving vertically downwards. So that's why a is equal to plus g. Wherever it reaches to the ground, near to reach to the ground, the velocity possessed will be v. So here whenever the body is freely falling, its initial velocity somehow wherever it is started from rest. So that's why a is equal to 0, u is equal to 0. Listen, whenever the body is falling freely from certain height, that initial velocity will become 0 whenever it is freely falling, whenever it is releasing. Otherwise, if in case of somehow throw that thing, then a object is thrown by by using the force, there will be some velocity will be there. Whenever it is freely falling, whenever it is released, then it is freely falling, then only the initial velocity u is equal to 0, a is equal to plus g, and s is equal to h, and its final velocity will be v. So from that, the equations of motion, kinematical equations of motion will be changes. The fourth one is Sn is equal to u plus a of n minus 1 by 2. So these equations can be changes as that is s is equal to h, a is equal to plus g, and initial velocity u is equal to 0, and final velocity v is equal to v, means the final velocity considered as v. So that's why we are substituting this equation. The first equation will be, that is v is equal to u plus at is changes as v is equal to v, that is equal to u is equal to 0 plus a is equal to plus g into t, means v is equal to gt be the equations of first equation of motion. And the second one is, second equation of motion will be s is equal to ut plus half at square. So s is equal to ut plus half at square, s is equal to ut plus half at square. If we substitute those values in this case, we can write that s is equal to, instead of s, h, that is u is equal to 0. So the total term becomes 0, 0 into t, 0, then half, instead of a is equal to plus g we have. So that's why g t square, that means h is equal to half g t square. So this is the second equation of motion. In case of third equation of motion, v square minus u square is equal to 2as. V square minus u square is equal to 2as means v is equal to, we have that is v square minus 0 square, that is equal to 2g, s is equal to h. A is equal to g, s is equal to h. From that equation we can write that v square is equal to 2gh, and also this is the one of the equation, and also we can write that v is equal to root 2gh. Also we can write these two equations can be write from the v square minus u square is equal to 2as. The last one is the fourth equation can be changes as Sn is equal to u plus a of n minus 1 by 2 can be changed as Hn is equal to u is equal to 0. So that's why a is equal to g of n minus 1 by 2. This is the, by substituting the values we can, these are the equations whenever the body is freely falling from certain height, equations of motion for a freely falling body. Then if in case of the body is projected vertically upwards, means equations of motion, equations of motion for a vertically projected body, vertically projected body, vertically projected body. Whenever the body is projected vertically upwards, then here let's see, whenever the body is projected vertically upwards, it consists of some initial velocity, that is s, and it did not reach the maximum height, so that's why there is a final velocity is also there. It is before reaching the maximum height, before, whenever the body is projected vertically upwards, means initial velocity is there and it is under motion, then it is having the final velocity is also there. It didn't reach the maximum height, so only it reached us, the possess the final velocity will be there, and s is equal to h. When the body is projected vertically upwards, which is the opposite direction to the gravitational attraction, means the acceleration due to gravity will be negative, which is moving more than the gravitation. If the body is acting on the gravitational effect acting on the body, above that, beyond that, the body is moving opposite direction to the gravitational attraction. So that's why here the A will be, acceleration due to gravity will be minus g, acceleration due to gravity will be minus g. Here initial velocity is there, final velocity is there, the displacement will be s is equal to h, distance travelled by a body, and acceleration due to gravity will be a is equal to minus g whenever the body is projected vertically upwards. It is not making an angle, either moving the vertically upwards or downwards. Along the straight line it has to move in the along the x-axis or along the y-axis. It has to move in the single direction along the straight line. Whenever they are moving the straight line, then only equations of motion can be written as. If in case of if the body is changes its direction whenever it is in the air, or here also we are not consider, we are ignoring the air resistance. We are ignoring the air resistance. If in case of the air resistance can be considered, then we can get the another equations. We are ignoring the air resistance here. So then only in the freely falling body case also, in the vertical upward body case also, we are ignoring the, we are not considering the air resistance. So here it is that A is equal to the first equation of motion, V is equal to U plus AT. That can be V is equal to, we have velocity, V is equal to, U is equal to velocity, we have A is equal to minus G into T. This is the first equation of motion whenever the body is projected vertically upwards. And the second one is S is equal to UT plus half AT square. UT plus half AT square be the second equation of motion. So by substituting this, S is equal to H we have, A is equal to G we have, and U is equal to U is there, V is equal to V. Velocities are didn't change because of whenever the body is projected, it is having initial velocity as well as it have final velocity also. So S is equal to UT plus half AT square. We are substituting, instead of S is equal to H we have, so H is equal to UT plus half. Instead of A we have that minus G into T square. So H is equal to UT minus half GT square. This is the equation for second equation of motion for vertically projected body, and the third equation will be v square minus u square is equal to 2as. V square minus u square is equal to 2as, then we can get that v square minus u square is equal to minus 2gh, minus 2gh. These are the equation for the velocity displacement relation. V square minus u square is equal to minus 2gh. If in case of the body, whenever they reach to the maximum height, at maximum height the velocity becomes 0 but not acceleration. So here it is that whenever the final velocity becomes 0, then only we can get that u is equal to root 2gh. That is the furtherly we will discuss in the parameters of a body. So here it is the third equation. Then the last one is fourth is Sn is equal to u plus a of n minus 1 by 2 be the equation of motion. Then from that equation Hn is equal to S is equal to H, we have u, a is equal to minus g of n minus 1 by 2. This is the equation of motion whenever the body is freely falling from certain height, or either the body is projected vertically upwards. Once again, when the body is falling from certain height due to the gravitational effect, that is called as the acceleration that body possesses, so that is called as the acceleration due to gravity. Means the acceleration of a freely falling body due to gravitational attraction is called acceleration due to gravity. It is denoted with a small g, and value of small g will be 980 centimeter per second square, or in case of meters 9.8 meter per second square. Feet will be 32 feet per second square. Then equation of motions, when the body is freely falling, motion of your body when from certain height, if it is moving under the gravitational attraction towards the ground, then that is called as a free fall. In that case of free fall, the acceleration due to gravity will be positive, means a is equal to plus g. So in that plus g, we have the equations of motion. 4 equations of motion is there. From that, by substituting, whenever the body is falling from certain height, its initial velocity becomes 0, u is equal to 0, and s is equal to the displacement distance traveled by a body, s is equal to h. From that, here in a straight line, displacement and distance both are the same, because of there is no change between the displacement and distance when the body is moving along a straight line in the same direction. Then a is equal to, it is moving under the gravitational effect, so that's why a is equal to plus g. We are substituting these two total values in the equations of motion. From that we can get that from the first equation of motion will be at v is equal to gt by substituting the values. From s is equal to ut plus half at square, we can get the u is equal to 0, so total term becomes 0, that is h is equal to half gt square. And the thing is v square minus u square is equal to 2s. From this relation v square is equal to 2gh, or v is equal to root 2gh also we can write. And for fourth one is Sn is equal to u plus a of n minus 1 by 2 be the nth second distance travelled by a body in nth second, that is Hn is equal to g of n minus 1 by 2, because of u is equal to 0 and a is equal to plus g. So g of n minus 1 by 2. And in case of if the body is projected vertically upwards, it didn't reach the destiny, means the body didn't reach the maximum height, only it is projected vertically upwards. So here it is that whenever the body is reached to this, here is also we can write that it is having velocity, it didn't reach to the ground. Here is also same thing, it didn't reach to the maximum height, did not reach to the maximum height. So that's why whenever the body is falling, moving vertically upwards, projected vertically upwards, then its acceleration due to gravity is moving opposite to the gravitational attraction, opposite direction to the gravitational attraction. So that's why acceleration due to gravity will be a is equal to minus g. So s is equal to h, then initial velocity is there and final velocity is also there. By substituting these values in the kinematical equations of motion, then we can get v is equal to u, a is equal to minus d is there. So that's why minus g, u minus gt is the first equation of motion. And then the second one is h, s is equal to h, we have ut means ut, and of gt square means of at square means plus by a is equal to minus g is there. Whenever we multiply this one, then h is equal to ut minus of gt square. Then in case of the third equation of motion, that is v square minus u square is equal to 2as. By substituting v square minus u square is equal to a is equal to minus g is there, so that's why we can get that minus 2gh. The fourth equation will be Sn is equal to u plus a of n minus 1 by 2 there. So Hn is equal to u minus of g into n minus 1, because of a is equal to minus g when the body is projected vertically upwards. This is about when the change of equation of motion, change of equations of motion when the body is freely falling and projected vertically moving upwards. These are the changes of equations. By using these equations we can find out the parameters. What are the parameters which are involved by the body during its motion? Means whenever the body vertically projected upwards, then what are the parameters which is involved? We can, when a body is projected from certain height or from a top of a tower, then the motion of a body thrown vertically up from the top of a tower, then what is the value, what is the distance, we can find out. Means a body, a tower of small h AB, a tower of small h AB. From this tower, a body is projected vertically upwards to reach its maximum height C, to reach the maximum height C, and after reaching the point C, and the body will started falling downward direction and reach to the point of foot of the tower. Means AB is the small h is a height of the body, means a tower, and whenever our body is projected vertically upwards, reach the h height to C, reach the C, and after it is downwards falling. The distance travelled by a body in projected direction can be taken as positive, and opposite direction taken as a negative. Means vertically upward direction taken positive and downward direction taken as a negative. The total height will be h plus h, means that is a minus. The upwards taken as plus h, and downwards direction will be minus of h plus h, means the value which has taken. The height reached means vertically upwards, the height reached, or we can say that the displacement reached vertically, that is s is equal to plus h, and in the direction of whenever the body is projected vertically upwards and the total from the height of small h, then it reaches down falling. Means the displacement of a body, means here we can say that BC is equal to plus h and CD is equal to minus of h plus h. Then the total displacement will be from B to D. B to D means here the distance which is equal to h, means here the body displacement is in this direction, so that's why we can consider that is s is equal to minus h, as well as we can get the same thing because of by adding the two equations, then BC plus CD that is equal to, we can get that h minus of h plus h, that is equal to minus h. The total displacement, net displacement s is equal to minus h. And the acceleration due to gravity, that is a is equal to minus g, because of it starting upwards. The body started upwards, projected vertically upwards, so that's why a is equal to minus g. Then reached s is equal to minus h, and it is having that initial velocity, and also that is u is equal to the time taken by the that is t. So that's why we are substituting this from s is equal to ut plus half at square, that is the equation of kinematical equation, second equation of motion. So from that equation we can write s is equal to minus h, u is equal to u, t, we have that a is equal to minus g. So if you substitute that one, half of minus g into t square, so minus h is equal to ut minus half gt square, we can write that, or in this case of we can write that minus h is equal to ut minus half gt square. By taking this minus means h is equal to minus ut plus half gt square also we can write. This is the equation for whenever the body is projected vertically upwards from the top of a tower. Motion of a body from the projected vertically up from the top of a tower, when the direction can be taken, the direction of projected side, whenever in the what direction we have projected, if the displacement distance traveled by a body in the same direction taken as positive, and opposite traveled distance can be taken as a negative. So that's why we have taken that the plus h and c is equal to minus of h plus h. The net displacement will be h minus of h plus h. So that's why we can get that minus h, and the time taken by the body is t, and acceleration due to gravity, that is a is equal to small g, because of at the starting stage we applied a force. So that's why we will consider whenever the body is projected direction. So that's why here a is equal to minus g. From these total values we are substituting in this kinematical equation of motion, second equation of motion, that is s is equal to ut plus half at square. We can get this equation, a minus h is equal to ut minus half gt square, or h is equal to minus ut plus half gt square. By using this equation, so we can find out the what the height, at the what height the body can be projected from the top of a tower or at some height. Let's discuss about some problems in a motion in straight line. From the starting that, here we are discussing about a car travels the first third of a distance with a speed of 10 km per hour, the second third at 20 km per hour, the last third at 60 km per hour. What is its mean speed over the entire distance? What is the total? Is nothing but the equation for the average speed. So we know that formula for average speed means here the body started from our point and reached another point which is having the 3 stops, means it's the first one, total 3 divisions it is have. The car travels first third of a distance, that is velocity v1 with 10 kmph means kilometer per hour, and it consider A, B, C, D. From the B to C, that will be velocity V2, that is 20 km per hour, and at the last third one is V3 is equal to 60 km per hour. So here it is the V1, V2, V3 values are given. From the relation we can write that the average velocity, whenever the 3 velocities are given, the equation is 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. This is the relation we have. Already we discussed about this one. So that is 3 into what is v1? 10. We are not changing this one. We will finally, at the result we can change into the meter per second. Now we are taking it in kilometer per hour. So 10 into 20 into 60 by v1 into v2, 10 into 20 plus 20 into 60 plus the next one is v3 v1, 60 into 10. So here the values are here 10 20, can continue this one, here 3 zeros is there, 6 to the 12, 12 3 is 36, so 36,000. So totally 36,000 be the 3 into 10 into 20 into 60, 3 10s are 30, 30 20 600, 600 into 60, 36,000. Then from that 10 into 20 200 plus here the 20 into 60 1200 plus 60 into 10 600. From this relation 36,000 by 1200 200 1400 1400 600 2000. So 2000. Here 3 get cancelled, 2 ones are 2 18s are 18. So 18 kilometer per our average speed. To change this into meter per second, we can multiply 18 with 5 by 18. Then we can get there 5 meter per second. 5 meter per second is the value of average speed, mean speed, whenever the car travels from the first total distance, entire distance. 5 meter per second be the value of average speed, average or mean speed, mean speed, that is equal to 5 meter per second. This is about. The next problem is a bullet moving with a speed of 150 meter per second strikes a tree and penetrates 3.5 centimeters before stopping. What is the magnitude of its retardation in the tree and the time taken for it to stop after striking the tree? After striking the tree. So here is the values. We can get that a bullet moving with a speed of 150 meter per second means a bullet speed is u is equal to 150 meter per second, and the strikes a tree and penetrates 3.5 centimeters. The displacement strikes a tree and 3.5 centimeters means the displacement which has happened 3.5 centimeters, which can be transferred into the meter per second, means it is in CGS system, so we should convert into the SI system. So a bullet moving with a speed of 150 meter per second, that is initial velocity u is equal to 150 meter per second, and it penetrates 3.5 centimeters, means the displacement s is equal to 3.5 centimeters, that can be converted into the meter per second, that is 3.5 into 10 to the power of 2 meters. So here it is. Then here before stopping means it already body it comes to rest, that is velocity, final velocity will becomes a 0. Then what is the magnitude of retardation? He asked for retardation from v square minus u square is equal to 2as. From this relation we can write that minus u square is equal to 2as, that is retardation means a is equal to minus u square by 2s. This is a relation of a retardation. Negative symbol indicates that retardation means here the retardation is depends on the velocity also. So that's why we are substituting the total values in the equation. Then we can get that a is equal to u square minus of 150 whole square by here 2 into 3.5 into 10 to the power of minus 2. From this relation by the calculation we can get that values, that is 3.214 into 10 to the power of 5 meter per second square. By the calculation we can get 3.214 into 10 to the power of 5 meter per second value. So from that value, another thing is, then he asked for another one also, what is the magnitude of retardation is in the tree and the time taken for it to stop after striking the tree. After striking the tree, then what is the time has taken to trip? Means stopping distance. Means whenever the retardation started, whenever it penetrates the tree, retardation started, then what is the time has taken to stop by a body? So here it is that the time is equal to u by a is the formula we have. From that formula we can write that t is equal to u means 150 by, here negative symbol indicates that retardation. So a is equal to 3.21 into 10 to the power of 5. From that relation also we can write that by the calculation 4.67 into 10 to the power of minus 4 second. The time taken to stop the body. Time taken to stop the body. Means here, consider it's a tree. When a bullet is started with initial velocity u is equal to 150 meter per second. Then it is penetrates through the tree and stopped at certain distance, that is 3.5 centimeter. Then from the starting it started penetration and stopped at some distance, v becomes 0. Final velocity becomes 0. So that's why then here we are going to know this, the retardation, how much the velocity goes on decreasing after penetrating the body. Then here another one is derive an expression for stopping distance. Stopping distance, what is meant by the stopping distance? Let's see, when we are riding the bike or when we are riding the bicycle, If we apply the brake, immediately that body cannot be stopped. It will move for small distance until it stops. The time between the distance travelled by a body to stop after applying the brake, the distance travelled by a body after applying the brake, the distance travelled by a body before stop, the distance travelled by a body before stop after applying the brake is called stopping distance. Stopping distance means we apply the brake and that body has moved some distance and stop. So the distance travelled by a body after applying that brake is called stopping distance. So here it is that body is moving with initial velocity u and that is stopped at distance of some of the distance travelled. So v is equal to 0. Then s be the displacement, that is stopping distance. From the relation, so simply we can get that from the v square minus u square is equal to 2as also we can write that, and as well as here we want to know this, here s is equal to s and a is equal to a and v is equal to 0 minus u square. Here negative symbol indicates that the retardation. Here we are already discussed about the retardation discussed. So that's a minus u square by 2a that is equal to s. This is the formula for stopping distance. Here this is about the problems which are important in the motion in a straight line. Knowing the equations of motion of a vertically projected body, then what are the parameters when a body is projected vertically upwards? Then what are the parameters? We will discuss about it. So when the body is projected vertically upwards means when the body is projected with initial velocity u, and whenever the body is moving vertically upwards, its velocity goes on decreasing, means it having the retardation. The velocity goes on decreasing until it reaches to the maximum height. At maximum height, the velocity becomes 0. The velocity becomes 0. So here the parameters, one is the involved, that is one maximum height. It is denoted with a h maximum. H maximum means whenever the vertically projected body at the height by the vertically projected body, its velocity momentarily is 0. The height the vertically projected body's velocity momentarily becomes 0. The height is called as a maximum height. Here the definition of maximum height is the height of a vertically projected body velocity, vertically projected body velocity momentarily becomes 0, means that is goes on decreasing, the velocity goes on moment by moment, that goes on decreasing, finally it becomes velocity becomes 0 at some height, becomes 0. The height is called maximum height. The height is called maximum height, that is denoted with h maximum. Means a body is projected vertically upwards from initial velocity with initial velocity u, and whenever it reaches to it moving vertically upwards, the velocity goes on decreasing, means the velocity, whenever the velocity is decreasing, that is a retardation is possessed by the body until it reached at a height, the velocity becomes 0. That height s is equal to h maximum. The height will be h maximum. So time taken by the body is t. So here the h maximum is equal to, from the formula v square minus u square is equal to 2as. From the formula v square minus u square is equal to 2as. From this formula we can write that we know that v is equal to 0, means 0 square minus u is equal to initial velocity is there, so u square 2. But whenever the body is moving vertically upwards, a is equal to minus g. The acceleration due to gravity is a minus g, so that's why minus g. S is equal to, we have h maximum. H maximum, so that's why minus u square is equal to minus 2g h maximum. From that minus minus get cancelled, then from the h maximum we want to know this. H maximum by a vertically projected body is a u square by, whenever the 2g taken to this side, it will becomes a denominator, that is h is maximum is equal to u square by 2g. This is the one of the parameter which is involved by the vertically projected body. When the body is vertically projected vertically upwards, the height of a vertically projected body, velocity momentarily becomes 0. Where velocity momentarily becomes 0, the height, at that height is called as a maximum height. From the kinematical equation of motion, we substitute this equations, then we can get. The next one is when the body is reached to the maximum height, then the time taken by the vertically projected body to reach the maximum height is called a time of ascent. The second parameter of a vertically projected body is a time of ascent. Time of ascent, that is denoted with a small t suffix a. Small t suffix a, time of ascent. So here it is that the time taken by the vertically projected body, vertically projected body to reach maximum height, maximum height is called a time of ascent. Time of ascent is denoted with the TA. From wherever that is, here is the diagram, we can take that the t is equal to TA, the same values which can be applied. From v is equal to u plus at, from v is equal to u plus at, then we can write that the time of ascent will be a is equal to the, here v is equal to 0, v is equal to 0 is equal to u minus GTA. From this, if in case of minus GTA taken this side, then GTA is equal to u, TA is equal to u by g, with the formula of time of ascent when a body is projected vertically upwards. Means the time taken by the vertically projected body to reach its maximum height, is called time of ascent. After reaching the maximum height, the velocity becomes 0, but its acceleration is not 0. When the vertically projected body, velocity becomes 0 at maximum height, but its velocity becomes 0, but its acceleration do not 0, so that's why that body will return to the same point of instant. So that the time taken by the vertically projected body to reach the same instant, means to the ground, like this. When the body is projected vertically upwards and reached velocity becomes 0, and again the body reached to the ground point of, it is vertically upwards, it is moving downwards. Here a is equal to minus g. In case of descent, a is equal to plus g. A is equal to plus g, and velocity will becomes here u is equal to 0, and here is also v, final velocity v is equal to u, here u is equal to 0. The vertically downwards body, freely falling body, the initial velocity is 0 and final velocity will be the equal to the distance what is the projected velocity. So that's why we can write that here the velocities become 0, here the velocities are same. So that's why the initial velocity v is equal to u, that will becomes. So the time taken by the time of descent, means the time taken by t suffix d be the, we can denote with this one, the time taken by the body to reach the ground from the maximum height. The time taken by the body to reach the ground from maximum height. Either we can write other things also. Time taken by the vertical projected body, vertically projected body to reach ground, to reach ground from maximum height. Maximum height is called a time of descent. T suffix d. It is denoted with td, as well as the time of ascent, which is equal to time of descent. We can get that. So from that equation we can write that here the velocity will be, initial velocity will be u, v is equal to u plus cat is the first equation of motion. So from that equation v is equal to u, we have u is equal to, in case of u is equal to 0, a is equal to g, that is suffix d, td, td be the time of descent td. So that's why we are writing that td is equal, directly we can write that u by g. Here the time of ascent and the time of descent both are the same when air resistance is neglected. Ta and td are same when ignoring the air resistance. Air resistance. If in case of air resistance is considered, in case of air resistance is considered, the time of descent will be more than the time of ascent. If air resistance is considered Td is greater than Ta, means time of descent is greater than time of ascent. So here is also we can write that the velocity of a vertically projected body becomes a 0 at maximum height. But acceleration do not becomes 0. Acceleration not a 0. That is A is equal to G. A is equal to G, because of whenever after reaching the maximum height that body will return to the ground. So that's why due to the gravitational attraction under the gravitational effect. So that's why here we can write that the velocity of vertically projected body becomes 0 at a maximum height, but acceleration not 0. That is A is equal to G. So here the velocity and the time of ascent, the maximum height and the time of ascent and the time of descent, and another one is also time of flight. Time of flight be the another parameter of a vertically projected body, means the time taken by the body to be in air from the point of instant to the instant that body reached to the ground is called a time of flight. Simply we can say that the time of a body, the time be in air, the time taken by the body be in air from the projection and reach it to the ground. Between this the body will stays at on the air. So that's why the time, the body, how much the time is in air is called a time of flight. Time of flight. So another parameter of a vertically projected body is a time of flight. Here the time of flight means the time spent by a body, by the body, the time spent by the vertically projected body. The time spent by the vertically projected body to be in air from the instant from the instant it is projected, from the instant it is projected to reach the instant it reaches the point of projection, means where the point is projection is this one, and after moving the body vertically upwards, the point from the instant of point of projection to the instant it reaches to the point of projection, means to be in air from the starting when the body is projected vertically upwards and reach it to the same point of projection. The instant between the projection and to reach the point of projection, the time spent by the body in air is called a time of ascent. That means to say, when the body is projected vertically upwards, this is the point of projection. So whenever the instant, the time spent by in air by the body, by the vertically projected body, and from the instant of projection to reach the instant it reaches to the point of projection. So the total time spent in the air is called as a t, that is a time of flight, means this is the time of ascent and a time of descent. Time of ascent and a time of descent means the time of flight is equal to time of flight is equal to time of ascent, time of ascent plus time of descent. By adding the time of ascent and time of descent, we can get the time of flight, time of descent. So that's why here that the time of flight is equal to time of ascent plus time of descent. We know the formulas time of ascent and time of descent. So that's why the t is equal to UTA plus t suffix d. So from the t is equal to a is equal to u by g, and this is also u by g. We already know this. Whenever the air resistance is neglected, then the time of ascent which is equal to time of descent. Otherwise, if air resistance is considered, then air resistance due to the air resistance, the time of descent will be more than the time of ascent. So here it is that t is equal to 2u by g be the time of flight. These are the four parameters of when a body projected vertically upwards. This is about parameters of a body projected vertically upwards.